This is the video for Unit 1, Lesson 2, Functions and Intervals. The goals of this video are going to be to identify positive and negative intervals of a function. And then we're also going to identify increasing and decreasing intervals of a function, very similar to how we did back in Math 1. So the first topic we're going to be looking at is positive and negative intervals and what that means in terms of a definition. So we're going to use, again, the example of a quadratic function, right? So this right here, again, is a quadratic. And when it asks for a positive or a negative interval, what that basically means is we're thinking about it in terms of a function. So when we talk about f of x is actually the same as saying y, right? So y equals f of x equals, those represent the same thing. So when it says a positive interval are values of x where f of x is greater than 0. So that basically means we're looking for when y values are greater than 0, right? And then we name the interval using our interval notation we learned in the previous video and then that we also have used before. So what we do for when we want to know when we have a positive, we're basically going to look at our graph. And I'm going to erase that right there. We're going to look at our graph, and I'm going to kind of divide it tracing the x-axis, right? So all the y values on the x-axis have our value of 0. So y equals 0 when we look at all the values that are on the x-axis. For values that are above the x-axis, the y values are actually greater than 0. And for y values that are lower, those are y values that are less than 0. So really what we're looking at is what parts of the graph, when we want a positive interval, what parts of the graph are really above the x-axis. That's really what that's saying, right? So what parts, when is the graph above that green line I drew or above the x-axis? And a negative interval, same definition, but basically when it's less than 0. When is it below the x-axis? So when they're talking about positive and negative intervals, we're really just dividing the graph, the graph up, and we're looking at what parts of the graph are above the x-axis, what part are below. So when we look at what's above, you can see these two parts of the graph are actually above. When it goes off the graph, we thinking about when it goes to the left, it's negative infinity. When it goes to the right, it's positive infinity. Notice we're only describing, it's describing the y values, so we're only listing the x values. So if it goes off the graph in this direction, it's negative infinity to the left, positive infinity to the right. Again, we're not talking about end behavior. We're describing the x values. So we can see it goes off the graph here. So when it goes to the left, it basically goes from negative infinity up until where it intersects the x-axis. So that's our x-intercept. So up to -3. So that's one part where it's positive. And then it's also positive or above at 1 up until, and then it just goes on forever. So up to positive infinity. Another way that we write it is we can use, when we use our notation, we can also say it goes from negative infinity to -3. And then the math version of saying and is the little intersection, our union, so u, and then 1 to infinity, right? So there's actually two parts of the graph that are above that green line. For the negative interval, that's when it's below. So you can see that it's actually below right here. So it actually has a beginning and an end. So we can see it starts at -3. I'm not going to include that point because it's not increasing or decreasing or anything at that point. And then it stops at 1. So it goes from -3 to 1. That's our blue. So the function is negative from -3 to 1. And again, these intervals are all describing the x values. So you're using the x values to list your answer because your y value is being described by saying positive, negative, increasing, decreasing. So we list it with just our x values. An example of this you can see for example 1. We're going to determine where it's positive and negative, and we're going to do the same thing we just did above. So I'm gonna actually kind of make a line. That's my x-axis. So anything above this line is going to be positive. Anything below this line is going to be considered negative. Anything that's an arrow, if it goes to the left, it goes to negative infinity because we're describing our x values. And then if it goes to the right, describing with our x values, it's going to positive infinity. So the function is positive. You can see it starts at 1 to 3. I'm going to use a parenthesis. And then it's actually negative at 2 different parts. It's negative from negative infinity, and I should say, sorry, negative 1. From negative infinity to negative 1. And it's also negative from 3 to infinity. And then this would be our final answer. For the you try, again, that's part of your assignment. So you want to make sure you complete that. You're going to show us that to get full points. But it's same concept. And now we're going to move on to our next topic. Our next topic is very, very similar. You actually did the same topic in Math 1. And so this topic is talking about increasing and decreasing intervals. So very similar. We only answer with our x values. Same thing, when I go to the left, I'm telling that's negative infinity. When I go to the right, I'm saying that's positive infinity when we're talking about our x values. And instead of just saying positive and negative, we're talking about increasing and decreasing. So what we typically like to do is first identify all of our maxes, which is our highest points, all of our mins, which are the lowest point, or any like inflection point. So where do things start to change? So I could see for this function, I have a lowest point, I have a min value. And so I'm going to use this min, and this min happens at a x value of negative 1, a y value of negative 5. That's actually our vertex. But I'm only going to use that negative 1. I'm not going to worry about that negative 5 because that's going to be, negative 4, because that's going to be our lowest point. And so now, I know that when it goes off the graph in this left direction, this is negative infinity. This is our positive infinity. And then when we talk about increasing and decreasing, we always go from left to right, right? Just how we read a book. So when I go from left to right, I could see from negative infinity to negative 1, it's actually going down. And then when I go from negative 1 to positive infinity, it's going up. So I can see if I want to write my increasing, and actually I'll start with decreasing because if we go from left to right, goes from negative infinity to negative 1. And then my increasing goes from negative 1 to infinity, right? So I'm just going from left to right, like how we read a book. And then when does it go down? When does it go up? For the example, you can see the example is more of a function where it's kind of like a piecewise function. It doesn't have arrows, so we might see, this is our first example, we're maybe not going to see infinity, but we're going to do pretty much the same thing. So we can see that if I go from the left, if it went off the page, it would be negative infinity. If it went off the page in the other direction, it would be positive. But you can see there's no arrows, right? So I'm not even going to have to use that for this example. So when I go from left to right, just how we read a book, I go from the left, I see I'm increasing. I then have a part where I plateau or go, it's a constant. I don't have to list that. And then it's increasing again. I then can see when is it decreasing. It's decreasing right there. I can then say, well, what are my points here? Well, this point is -6, -4. This point is -1, 1. This point here is 2, 1. This point here is 3, 1, 2, 3, 3, 4. And then this last point is 6, -1. But again, we only use the x values. So I don't care about those other values at all. So when we list this out, my increasing is actually from -6 to -1. It's also from 2 to 3. And then the last one here is going to be from 3 to 6. So you can see, and again, you're only using those x values. The last question is a U-try. So again, that's part of your assignment. So you're going to try that, and then we'll check that in. And if you have any questions, feel free to ask them in class during T-Bolt time or get help in the center.